Hi, my name is Andrew, and I'm going to go over my project, SensorNet. SensorNet is a distributed mesh network that focuses on collecting sensor data, sending that data to a central source, and then processing that data to create valuable insight and help people understand problems or situations in an easier way. The SensorNet project is primarily split up into two parts. We have the node firmware, which does things like monitoring sensor inputs and transmitting data. And we also have our monitoring application, which takes in the data and performs different types of analysis. The nodes each collect different types of data. So these two nodes are collecting data. Then they transmit that data over a mesh network, and it's received by this receiving node right here. Whenever this receiving node receives the information, it reports it over USB serial to the monitoring application, which then processes that data to create insight. Each node consists of several parts. The first and main part is the Heltec V3 board that's ESP-based, and it has a LoRa radio module and a ULCD display. Attached to that, we also have different types of sensors. This node has a temperature sensor, but it can not have a sensor, or it can have a different type of sensor, like a barometric pressure sensor. And there's also the optional battery there in the back. So now I'm going to show the project in action. As you can see, we have our two sensor nodes set up. We have our pressure node is currently reading about 989. We also have our temperature node set up. It's about 25 degrees Celsius. And these two nodes are set up so they're transmitting their information over to our receiver node. As you can see, the receiver node is currently detecting two sensors and it's listening. So that's connected into this computer where we have the monitoring application running. So here we are inside of the monitoring application. The monitoring application connects to the receiving node over serial. So as you can see, we're connected to the USB serial device number 1. And it shows you pretty much all of the information that the node is receiving. So you can see different types of temperature information that's being read here. We can see it going back through time. And we can also see barometric pressure back through time. Down on the bottom, we also have more raw data. For example, the packet inspector, where you can see all of the packets that the node is receiving and valuable information, like the RSSI, SNR, and how many hops it took for the signal to make it to this node. Because our demo nodes are so close together, it's all at 0, but these nodes do have routing built in, so they can handle multiple hops. We also have derived insights. Now, derived insights is special because it actually does data processing. So if I just kind of put my finger on the temperature sensor here, it may take a few seconds, but that will start to heat up. And we'll see that, there we go. The temperature is rapidly rising at about 3.2 degrees Celsius per minute. And that's an anomaly. So the system detects a heating trend. I'll go ahead and remove my finger and do something similar to the barometric pressure sensor. I'll raise it up into the air. And you'll notice there's also a change in that. We'll get that reading change, and then it will detect another anomaly, just as it did with the temperature sensor. There we go. So I raise it up in the air, and so the pressure drops. On the very right-hand side, you can also see all of the mesh nodes that are detected, and we have our two nodes that are connected. Now, all of this insight is very valuable because it's a lot more than just the raw data. Sure, we have access to the raw data, but all of the data is being stored, collected, analyzed, and it's presented in a format that's valuable to us and that we can actually get insight from, which is a huge part of Information Internetworks. One of the challenges that I faced in developing SensorNet was keeping things simple while still getting the core ideas across. For example, instead of implementing complex mesh routing algorithms, I instead focused on simple algorithms that can avoid duplicate packets and avoid collisions when transmitting and receiving. Another challenge was balancing communication range and power with cost. Radios that can go long distances and transmit with high power are great, but they come at a great cost. And I found that the Heltec V3 radios were good at a good balance between cheap radios, but also very capable and made the mesh routing part of it easy. Another part of the project that was super important to me was making sure that it was modular, expandable, and open. All of the source code for this project is openly available, and it's easy to modify and expand. Everything's modular, and if you want to add a new sensor or add different types of trend analysis, it's super easy to do, and there's plenty of documentation to help you do it. That's been a quick run through of the SensorNet project. I hope that you learned a lot from this video, but if you're looking to learn more, the documentation is always available for you to use, both on the website and the document that was uploaded. SensorNet is a great way to learn about mesh networks, data collection, and how to get insight from data, even if it may just seem like a cluster of numbers. And that's the fun part about information networks. So thank you very much for watching, and I hope that this teaches you something amazing.